All right, this is section 3.3 in our MathLinks 8 textbook on estimating square roots. We're going to start here at question 4 that says estimate the square root of each number to one decimal place and check with a calculator. So first things first, the number 72 is not a perfect square, is it, Wyatt? No, because it's not a perfect square because it doesn't have a number that when multiplied by itself gives you 72. And in fact, it's what we would call an irrational number because if I was to ask what number multiplied by itself is 72, the answer would be a long infinite decimal that doesn't repeat a pattern. So in order for us to figure out what it actually is without using a calculator, what we do is we estimate using a number line. And if we think about all of our perfect squares, 1 is 1 times 1, 4 is 2 times 2, 9 is 3 times 3, 16, 25, 36, 49, 64, 81, and 100. Those are our first 10 perfect squares. If we think about the number 72, since 64 is a perfect square and 81 is a perfect square, right here and here, I'll just highlight them in green, we know that the square root of 72 will fit between those two numbers. So the square root of 72 is going to fit between there. So what I'm going to do is I'm going to put the square root of 64, which is 8, and the square root of 81, which is a perfect square, which is 9. And right off the bat, the square root of 72, is going to fit. Oops, that's not 72. The square root of 70. Oh, that's not even what I want either. What happened there now? The square root of 72 will fit in between there. So I'm going to use a red dot. Now 72 is 8 away from 64, and it's 9 away from 81. Is that right? It's 8 away from here and 9 away from there. So it's a little bit closer to 64 than it is to 72, but not by a significant amount, just a little bit less. So I'm going to put my red dot there, and therefore my approximation is going to be a little less than 8.5, right? The square root of 72 should be a little bit less than 8.5. I'm going to take my calculator to double check. What is the square root of 72? It's 8.48, which is just a little bit less than 8.5. Now the square root of 103, again, a non-perfect square, but we do know that it's going to fit between, if I keep going with this, it is going to fit between, if I can go the yellow highlighter, 100 and 121. It's going to be in between those. So on my number line, square root of 100 is 10, square root of 121 is 11, square root of 103, this time it's not going to go too far away. It's probably a lot closer to 100 than it is to 121, and therefore our answer is going to be maybe 10.1 or maybe 10.2 for an estimation. Grab your calculator. What is the square root of 103? It's 10.14. And finally, our last one, 55. What is the square root of 55? On our number line, 55 will fit between the square root of 49 and 64. So I'll put the square root of 49 over here. Oh, that's not what I wanted. Square root of 49, which is 7. Square root of 64, which is 8. So right off the bat, I know it's 7 decimal something. It's 6 away from 49 and 9 away from 64. So it's a little bit closer to 7 than it is to 8. And therefore, my estimation is going to be about 7.3 or 7.4. I have a funny feeling it's 7.35, but we'll see. Square root of 55. Oh, that was off. 7.416. Infinite decimal. We'll skip ahead to question 6. It says, what is an example of a whole number that has a square root between 9 and 10? Now the question itself is not difficult, but interpreting what it means, what the question is asking you, is difficult. So I'm going to show you this is really what it's saying. The square root of what number is 9 decimal something? Because 9 decimal something will be any number between 9 and 10, right? With square root between 9 and 10. So if we think about this using a number line, we know that the square root of 9 or 81 is 9 exactly. And we know the square root of 100 is 10 exactly. So any whole number between 81 and 100 will have a square root of 9 decimal something, right? All of the spaces on this number line will be 9 decimal something, or a square root between 9 and 10. So therefore, you could have said any number between square root of 82 has a square root between 9 and 10, square root of 83, dot, 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 square root of 99. All of those whole numbers have square roots of 9 decimal something. And we can just take 83 real quick and just, what is the square root of 83? It says 9.11. So it has a square root between 9 and 10. So your answer could be anything between 82 and 99. And question 8 is the exact same type of question. So the square root of what number, I'll use y this time, is equal to 2 decimal something, right? And 2 decimal something would be any whole number greater than 2 and less than 3. So our number line again, the square root of 4 is that 2, and the square root of 9 is that 3. So any whole number, square root of 5 will be between 2 and, square root of 6 will be between 2 and 3, square root of 7, and square root of 8. Those are all of the whole numbers whose square root will be between 2 and 3. All right, Kai uses an entire can of paint on a square backdrop on a school play. The label on the can states that one can covers exactly 27 square meters of wall surface, which we, of course, we know would be only an estimation. Estimate the backdrop's side length to one decimal place. So let's draw this square backdrop. Okay, so he's doing this big, massive wooden square backdrop that he's going to paint whatever color that is. And the area of that backdrop is 27 square meters. Well, real quick, what if the area of that square backdrop was 25 square meters? What would the side length have been? 5. So we know, just from experience in the last couple of questions, that probably this length is going to be just slightly bigger than 5, right? We're estimating. But we'll use our number line. The square root of 25 is 5. The square root of 36 is 6. I'm not recording. Yes, I am recording. And therefore, the square root of 27 is probably around there, which I'm going to guess is roughly 5.2 meters, roughly. And I'll use those wavy lines for approximately 5.2. Double check my answer. Square root of 27, 5.19, which would round up to be 5.2. Question 12 says, while shopping online, Ji-Hoon finds a square rug with an area of 11 square meters. He needs to know if it will fit in his 4x5 bedroom. So I'm hoping that the creative people in this room drew this first. This is his room, a 4x5 bedroom. And then he has this rug that is 11 square meters. So the first thing we have to figure out is what? What is the side length of the rug? So the side length of the rug, without estimating, is the square root of 11, isn't it? So the side length of that rug is 3.3 meters, approximately, right? Will that fit into the room? Yes, it will. What if it was a 5x3 room? No. Because if this was a 5x3 room, and this rug is 3.3 meters wide, it would have to go up the wall on the other side, wouldn't it? Okay. But it's a 5x4, so yes, it would fit. And question 13. Stella is planning an outdoor wedding. She would like the square dance floor with an area of 115 meters squared. Like, I don't know, like if my wife on my wedding day says I have to have a dance floor with 115 square meters of surface area, I'm probably not going to walk down the aisle anymore because she's a little bit too particular for me. But anyway, she should be a little bit more flexible. She can go with a rectangular dance floor. It's not a big deal, Stella. It's not a big deal. Don't make it into an issue. But determine the side length of the dance floor to the nearest tenth of a meter. So we'll draw Stella's, whatever Stella wants, she can have 115 square meters. The side length will be the square root of 115. So the side length is roughly 10.7 meters. Rounded to the nearest meter. And then Stella finds out the dance floor will be made up of floorboards, which measure each 1 square meter. What are two side lengths the dance floor can be? So here's an interesting one. She could round down, which means she's going to put 10 squares this way and 10 squares this way. But that will mean her dance floor is too small, right? It'll only be 100 square meters. So if you put the 11 of them down on each side, that means the square area dance floor that she has is going to be 121 square meters. And which one do you think she'll choose? Do you think she'll choose the 100 square meter or the 121 square meter? Or are you just walking out saying, Stella, we're not having dancing anymore. That's it. We're done. No more dance. Too expensive. Yeah. I'm going to guess she's like, you know what? I'd rather have the dance floor too big than too small. Unless, of course, there was like crocodile pits on both sides of the dance floor. And if she extended it too big, you'd be swimming in the, I don't know. We'll just say that she chooses the 121. Or a better answer would be, who cares? Question 15, order the numbers from least to greatest. 7, the square root of 46, 5.8, square root of 27, and 6.3. My gut says that that's the smallest. Because I know the square root of 25 is 5, so the square root of 27 is just going to be a little bit bigger than 5. And we'll just double check. Yeah, it's 5.2. So I'm going to put in brackets here in red 5.2. And then I'm going to use the square root of 46. And since I know the square root of 49 is 7, I'm going to get this like 6.8 something, maybe 6.9, 6.8, 6.8. And once we have it now written, we're going to order them from smallest to largest. The smallest is the square root of 27, then a comma, then 5.8, then a comma, then 6.3, then a comma, then the square root of 46, then a comma, and then 7. So there's your answer for ordered from least to greatest. And I do believe in my heart that 7 is the greatest number of them all. It's great. It is the greatest number. And finally, question number 16. Okay, here we go with question 16. It says a fitness center will install a square hot tub in a 6x6 room. So the first thing I'm going to do before I even start reading any further, I'm going to get my brain around this. I got a 6 meter by 6 meter room drawn. Now I keep reading. They want the tub that they're going to put into the 6 meter by 6 meter room to be no more than 75% of the room's area. What is the maximum area of the hot tub? So what's the first calculation that we have to find, even though it didn't ask for us to find it, Calvin?
We need to find the area of the whole room.
Right. And that's a simple one, right? 36 meters squared is the area of the room. And now the second step is, if that's the area of the room, and this hot tub can't take up 75%, has to fill no more than that, then what we want is 75% of 36 meters squared. Translating this to a decimal, 75% of 36 meters will tell us that the hot tub can occupy no more than 27 square meters. So I'm going to draw, it's going to be a pretty big hot tub, isn't it? 27 square meters. So we're going to pretend it's like, probably like this hot tub. And the maximum it's going to be is 27 square meters in a room of 36 square meters. We good so far? What is the edge length, Gavin, of that hot tub? How do I calculate it? How do I calculate the distance of that square hot tub's length? Square root of 27. And I'm going to estimate it before I press that button. What do you think it's going to be? 5 point something. We'll say 5.1, 5.2, maybe, right? Square root button says 5.196. Now here's an interesting one. Normally, what do we do there? We round up. Can we round up? If we round up, we are making the edge length a little bit bigger than it should be, correct? If we round up to 5.2, we're making the edge length a little bit bigger than it should be. And therefore, it's going to occupy just a tiny little bit more than 75% of that room, isn't it? Right? So therefore, it's kind of a trick question. The longest side length we can have rounded to 1 is 5.1 meters. Right? Because if we go to 5.2, it's going to occupy slightly more than 75%.